Making a copper salt. This experiment will show you how to make salt crystals from an acid and an insoluble base. This example uses sulfuric acid and copper oxide base to make a copper sulfate solution. Salt crystals are then obtained through crystallization. You're provided with the following: Bunsen burner, heatproof mat, tripod and gauze, spatula, glass rod, 100 and 250 centimetre cubed beakers, filter funnel and conical flask, filter paper, watch glass and evaporating basin, and your initial reagents of copper oxide powder and sulfuric acid. The reaction between an acid and a base is known as a neutralization. Remember, acid plus base equals salt plus water. Bases are compounds which can neutralize acids. They can either be soluble or insoluble. Bases which are soluble are known as alkalis. For example, hydroxides of group 1 metals. Insoluble bases, like copper oxide, do not dissolve in water. You could make copper sulfate salt directly from copper and sulfuric acid, metal and acid, but this requires a concentrated acid, which is much more corrosive and dangerous to handle. It is safer to make copper sulfate by using copper oxide, which will react with dilute sulfuric acid. When heating up the acid, it is important not to let it boil. Gently heating decreases the chance of spillage and makes sure that the acid stays contained within the glassware. The increase in temperature helps speed up the rate of reaction when the base is added in the next step. Addition of the copper oxide base allows the neutralization reaction to begin. The H+ ions in the acid are replaced by the copper ions in the base, and this forms the salt. The H+ ions from the acid and the oxide ions from the base react to form water. The solution is neutral, meaning it has no charge. The salt consists of positive metal ions and negative ions from the acid. Together these charges add to 0. The solution turns blue as the reaction occurs, showing that the copper sulfate has formed. Adding the copper oxide in excess is a simple way to determine the end of the reaction. When the copper oxide no longer disappears, you know that all the acid has reacted. It is also easy to remove the unreacted copper oxide by filtration because it is insoluble. Filtration is required to purify the solution. You have formed your blue copper sulfate salt and water in the beaker, but you also have some black copper oxide base remaining. By filtering the solution, you can isolate the blue copper sulfate filtrate and discard the insoluble black copper oxide, which will not pass through the filter paper. Since the copper sulfate salt is soluble, it is not solid in solution. It dissolves in water, and so it will pass easily through the filter paper. We want to isolate the copper sulfate crystals, so now we need to remove the water. This concentrates the copper sulfate solution. Heating the solution with the water bath evaporates off some of the water, but the copper sulfate ions remain in the evaporating basin. The solution is then left in a cool place for more of the water to evaporate off slowly. Because the salt is soluble, the ions are dissolved in the solution. You can think of them as being pulled apart by the water. So, when the water is removed, the ions of the salt can come together and reform crystals. These copper sulfate crystals are effectively giant ionic lattices made up of oppositely charged ions.